Steve, I had a question of you about the trained dogs.
Okay.
There seemed to be a lot of enthusiasm for this idea. What are the impediments to it?
Money. No, not just money, but I think it's very, very timely, and I think there's a wave of influence, of enthusiasm across the field. I think what we need to do is expand it. One of the reasons I thought this was such a good audience to mention this for is that we really haven't focused so much on the cognitive aspects, but it seems to me this is one of the places that the dogs could be most useful. And so I think if we can get the interest of the right group of people, particularly the professional trainers that I think are often left out of these things because they're not scientists, but they're incredibly talented at teaching dogs how to do things quickly.
Do you think the owners would be concerned?
No, this is actually, so there's this ongoing trial with, small trial with rapamycin, as many of you may know, on the health of dogs. And we really worried about this. Would people be willing to use their animals in this kind of clinical trial? They've actually been overwhelmed with volunteers to use these. I mean, I think if you assure people, because to a lot of people, they like their dogs better than their kids, right? So if you assure people that you're going to be very, very attentive to the health, discomfort, and all, and if you think about it, they're going to get better, more detailed veterinary attention than a normal dog. Then it really has not turned out to be an issue at all.
My comment was just a bridge question in terms of how to handle the public opinion and the animal rights people that you don't see many people out walking their pet rat. You do see a lot of people out with their pet dog, and there are some issues involved in doing that research.
Yeah, I think that this has not turned out to be a problem because this is one of the nice things about it. Nobody cares really about the health of a rat. A lot of people care about the health of their dog. All you need to do is to convince people that your research not only has implications for improving and prolonging human health, but also has the implications of improving and prolonging your dog's health. That, like I say, the evidence to date has been this concern, which I had initially, has just not cropped up at all.
So two big picture questions that are at very disparate ends of the spectrum. The first is, we haven't really talked much about motivation in resilience and self-perception of resilience in the sort of growth mindset aspect that Todd Braver and Carol Dweck have been collaborating on, as well as some other people. So if there's some way to connect that, how are people different when they perceive or want to be resilient? And the other end of the spectrum is the gut-brain axis and its role in neurogenesis. So we've talked a lot about neurogenesis in these sessions, and can any of you speak to how that might be modifying some of the cellular things that you've seen? Either one.
You want to say anything about gut-brain interactions and neurogenesis?
Well, I mean, a paper came out 4 or 5 months ago by the Wolf Lab, which I think is the best evidence insofar in linking the microbiome with neurogenesis. And so I think it's just the tip of the iceberg in figuring out, the channels of communication between the microbiome and processes like neurogenesis and others in the brain.
Yeah, there was also a paper, I think it's still under review, but it's in a public forum where they also looked at the microbiome in terms of lifespan in the turquoise killifish. Dario Valenzano's group at the Max Planck in Cologne did that. And they're also looking into sort of changes in cognitive function from that. I think it's really important to think about the systemic environment and the brain. I think we a lot of times think about it in isolation, and it's not, and we're appreciating that a lot more. The bacteria are changing all sorts of inflammatory profiles. Senescence profiles are even changing due to that when they've done these sort of just human biomarker analysis on them. So I think it's something to keep in mind for sure.
There are also a handful of microbiome studies showing that there's a kind of bacteria that can, if it reaches the right concentration, can start to create an endogenous HDAC inhibitor. Whether that can cross the blood-brain barrier, we have no idea.
if I could just enter a cautionary note here. Things become highly fashionable in science, and the standards of proof tend to decline. So I would just say we need to be as critical as you were expecting about that. One of the things that I'm concerned about is that given the lack of enrichment, the absolutely depopulative environment that we keep our experimental animals in, almost anything that we do to them could be considered a form of enrichment and could enhance neurogenesis for just some trivial reason. I think we really don't think about the environment that we keep our animals in nearly enough.
Thanks. I'm thinking about there's many different aspects of improving cognition that have been presented. To me, I wonder about combination approaches and what makes sense, not just maybe additively, but synergistically. And I'll just throw out as a thought, combining Dr. Voss's, I'm sorry, this is a clinical trialist speaking, not a neuroscientist, but reconnecting networks with Dr. Gazway's approach to using the networks as something that might provide a synergistic bang for the buck. I'd love to hear people's thoughts about that. Or other combination approaches.
Yeah, I think combination approaches are fine and could be very useful ultimately when it comes to application. At least in my field and my take on cognitive training and brain stimulation in general, we're still a little bit at the discovery stage where we would like to know a little bit more about the mechanisms at play before attempting such combinations, because I think one of the difficulties is the parameter space of what you could combine with what is essentially infinite. And without better mechanistic knowledge of what our interventions are doing, it will be virtually impossible to explore that parameter space in order to come up with the most effective interventions if we do it at the level of evaluating them via the interventions themselves. That's my opinion, but I don't know.
Any other thoughts?
Yeah, just one thing towards that. So we've been doing. So in addition, sort of to the young blood stuff that we do, we've been looking at things like exercise, and the changes that are happening in the brain are completely different, which kind of surprised us. And to me, that indicates that there's not one way of improving. I think there's going to be multiple ways of improving. And if there is sort of parallel signaling pathways, then yes, we may be able to combine it. With respect to that. So I think just based on the biology, it seems that there are multiple ways of sort of getting to that. Some of them, you can make a brain almost look transcriptionally a little bit more like a young one. The other way, it looks completely different, but it still has some functional benefit. So I think that argues to your point in terms of combining things. I think as we learn more, we may be able to.
With that, then I think we'll end this session. Oh, one more speaker? One more question? Yeah. Second.
Is there effect, if people looked at the positive impact of having a pet, and how does it affect aging?
Yeah, there's actually quite a bit of work on mental well-being and pet ownership. However, if you talk to geriatricians, there's also the issue of people tripping over their pets. So, there's good and bad.
Okay, well, thank you very much to everybody. This has been a great session.